We are talking about linear word problems, and we want to be able to identify the rate of change in word problems, be able to identify the y-intercept in word problems, and write linear equations in slope-intercept form. So question number 2, Kayla's tracking the progress of her plant's growth. Today, the plant is 5 centimeters high. The plant grows at 1.5 centimeters per day. Write the linear model that represents the height of the plant after D days. What will the height of the plant be after 20 days? So we look at our equation down here, and we have m is the rate of change, and then we remember that our y-intercept, another way that we can think about our y-intercept, is the starting point. So b is our starting point, and when we're looking for our rate of change, we're looking for the units that have 2 units on it. So those are the 2 things that we need to find. So we need to find m, and m is going to have 2 units on it, and we need to find our starting point. So she's tracking the progress of plant growth. Today, the plant is 5 centimeters high. So starting from today, it's 5 centimeters, and that only has 1 unit on it. So this is going to be our starting point, which is 5 centimeters. The plant grows 1.5 centimeters per day. And here we have 2 units, centimeters in days, divided by the per sign, or separated by the per sign, which actually means divide. So our slope is 1.5 centimeters per day. And another thing that we notice is our y variable needs to go in the numerator. So our y-intercept, or our starting point, units are centimeters. That should match the units that are in the top of our fraction for our units. So now it says, write the linear model that represents the height of the plant after D days. So if we have y equals mx plus b, so y equals mx plus b, we can substitute these values in. Now, the thing that's going to change is, now the x variable in this case is going to be represented by d, because that's what they tell us to do. They say they want us to use d days, and we know that d is going to be the x variable because days matches what's in the denominator for the slope. So we always remember that the y units are in the numerator and the x units are in the denominator. So I'm going to substitute the values in right now, and y is going to stay the same. The slope is right here, is 1.5. We're not going to use x, we're going to use d for days. And then we're going to have the starting point, which in this case, the starting point is. Now we can substitute the values in. We have 20 days, so d is equal to 20. So we'll substitute that value in, and then we'll come up with what our y value is. So 1.5 times 20, that ends up getting us 30. 30 plus 5, so y is equal to 35. And so what will the height be of the plant after 20 days? So after 20 days, the plant will be 35 centimeters. And we can check all of these things. The y values would be the y-intercept, the y, what our solution will be, and the numerator for our rate of change should all be the same units: centimeters, centimeters, centimeters. And then our x variable in the bottom of our rate of change will have the same units. So this will be 20 days, 20 days, or excuse me, divided by days.